Boom! Yes folks, how are you going? Welcome to this new series of videos. In this series of videos we will be talking about Pythagoras Theorem. That is one of the topics that causes a lot of problems for a lot of students. Alright, so for example in the Caribbean setup where we're dealing with the CXC exam, by the time people get into Form 2, Form 3, that is when they would be having their first interactions with Pythagoras Theorem, and that is when most of the problems start. So you'll find students getting into Form 4 and Form 5 and they're still wibbly wobbly where Pythagoras Theorem is concerned, which means therefore that when they go into do trigonometry, you're carrying the problems from Pythagoras Theorem into that topic with you, and that will just compound the problems. So what I will do is to teach Pythagoras Theorem in a way that will allow it to just flow smoothly into the trigonometry. Alright, that means that it will be a little different to what you would see in most textbooks. It will be a little different to what most other teachers would do, but that is fine. This is a difference where we take in Pythagoras Theorem and trigonometry in mind, and whatever we do from the get-go, we're doing with both of those topics in mind. Good. So what is a triangle? Let me start with that. We all know what a triangle looks like. If we have a crowded shape somewhere, we could point out the triangle. A triangle is simply a plane shape that is bounded by 3 sides containing 3 angles. A right angle triangle is simply a triangle where one of the 3 angles is equal to 90 degrees. In mathematics, we have a special symbol that will tell us as soon as we see it, that is a right angle, that is 90 degrees. And that symbol is this little box in the corner here. So what I've done here is draw 2 identical triangles, which we will get to in a bit. But anytime you see this box, you know that is a right angle. I just want to take this little opportunity here to caution students. If you don't see the box, unless you have some other specific information that will tell you that a particular angle is a right angle, do not assume that that looking like 90 degrees is a right angle, right? If there's one subject where you don't have any room for how things look and how it seems, that's mathematics. So if you're looking at a diagram and you see an angle and it's looking like 90 degrees, before you assume that it is 90 degrees, you need to know exactly why you're thinking that is 90 degrees. So for example, when we're doing circle theorem, there are particular conditions that where as soon as you see those conditions satisfied, you look at the angle and you say, yes, that is 90 degrees. And you could explain why the angle is 90 degrees. So unless you see this little box, or you are in a position to explain why an angle is 90 degrees, do not assume that an angle is 90 degrees, even if it's looking like 90 degrees. Good? Alright, so with that in mind, we could go a little further into this thing about Pythagoras Theorem. Now the first thing that I will do here that will allow me to deviate from what people usually do is to name the sides of the triangle differently. So in most textbooks and with most teachers, they would just name the sides A, B, and C. Alright? But for my purposes, because we want to use Pythagoras Theorem as a platform to jump into your trigonometry, we're going to name the sides according to the regular size of the triangle. So we know that in the case of a right angle triangle, you have the hypotenuse, which by definition is the side directly opposite the right angle. So the hypotenuse is the same in both of these triangles. The hypotenuse is always the hypotenuse. The other 2 sides are what we refer to as legs of a right angle triangle. Right? This is not language that we normally use, but that is what it is, a legs. So you have the hypotenuse supported by 2 legs, if you want to put it like that. Good? The names of these 2 legs could differ depending on your reference angle. And this here is where we start to meld the 2 topics together, Pythagoras Theorem and trigonometry. Of course, we're not going to go into too much detail with the angles now. We will deal with that when we get into the trigonometry itself. So if my reference angle is here, then this being the hypotenuse, this side here will be the opposite side, meaning the side opposite the reference angle, or the leg opposite the reference angle. And then this side, because it is next to the reference angle or adjacent to the reference angle, this will be the adjacent side. On the other hand, same triangle, different reference angle. So this side, having been the opposite side on this triangle when this was the reference angle, this side will now be the adjacent side, because in this case it will be next to or adjacent to the reference angle on this situation here. By the same token, this side here, having been the adjacent side over here in the blue triangle, where this was the reference angle, across here, because it is now opposite to the reference angle, then this would now be the opposite side. Before I go further, I just want to make a short comment on the two angles. This angle here is the angle theta, right? That's the symbol there, right? Put that in brackets. This angle is the angle phi, right? So just as in algebra, where you have x and you have y as the two generic variables that we use to denote an unknown quantity when we do in general algebra is x and y. When we're dealing with angles, right, the unknown quantities are generally denoted by theta. That's the most common one, just like x in the algebra. And after theta, you have phi, just like how we have y in algebra. All right? And of course, with the symbols, with the theta, you have a kind of egg-shaped thing there with a horizontal line in the middle. With phi, you have a circle with an almost vertical line coming straight through the circle. All right? Just a little side knowledge to take note of. Of course, when we're doing the trigonometry, we'll get more into theta and phi and the relationship between those two angles and the ratios, etc., etc. But we don't get too far ahead of ourselves right now. So, same triangle. This black triangle is a duplicate of the blue triangle here. But the thing that changes is the reference angle, and as the reference angle changes, the name that you give to the respective sides will also change. Good? Now, what is Pythagoras Theorem? Pythagoras Theorem simply states that the sum of the squares of the other two sides is equal to the square of the hypotenuse. Or you could say that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Either way, it doesn't matter. So, let us just write it out in symbols here. Pythagoras Theorem states that the square of the hypotenuse squared, is equal to the sum of the squares of the other two sides. Good? So whether your opposite side is on this leg, as is the case in the blue triangle, or on this leg, as is the case in the black triangle, is still the opposite side, right? If your adjacent side is on this side in the blue triangle, or on this side in the black triangle, is still the adjacent side. So I want people to think always in terms not just a generic A, B, and C, where the right angle triangle is concerned. Think in terms of hypotenuse, opposite, and adjacent. That is setting the tone for your trigonometry. Alright? Now, this basically is it, you know. So if I use a generic example, let us say we use the case where your hypotenuse is 25, you have a long side of 24 and a short side of 7. Right? And this particular trio of numbers you'll see a little later in the series. So let me say the length of the hypotenuse is 25, the length of this side is 7, and the length of this side is 24. Good? Same triangle over here, same length. 25, this will still be 7, and this here is still 24. So on the blue triangle, yeah, Pythagoras theorem would be that, and I'm going to use, in fact no, Yeah, we got to change the color of the ink to make the thing a little more interesting. All right. With the blue triangle, your Pythagoras theorem would be that 25 squared, which is the hypotenuse, is equal to the sum of the other two sides. It doesn't matter whether you put, let me use the base, well, opposite squared plus adjacent squared. Let me use that template, right? Opposites, in this case, the opposite is 7. 7 squared plus adjacent, 24 squared. On this side, your hypotenuse squared is still, in this case, the opposite is 24 and your adjacent is 7. Now, because the operation of addition is what we refer to as commutative, which is to say that the order doesn't matter, then the order doesn't matter. So 7 squared plus 24 squared is the same thing as 24 squared plus 7 squared. This h here is supposed to be 25 by the way. Alright? So in other words, when you're doing Pythagoras theorem, the order in which you add the squares of the other two sides is not important. Right? Opposite squared plus adjacent squared is the same thing as adjacent squared plus opposite squared. 7 squared plus 24 squared is the same thing as 24 squared plus 7 squared. Of course, you always have the hypotenuse squared by itself on one side of the equation. And that is basically it. That is your foundation. That is your foundation. Of course, when you get the foundation, you have to build the house. You have to build on the foundation. You don't just leave the foundation there. Good. So in the next video, we will do some examples to show the use of Pythagoras theorem in finding the lengths of the sides of any right angle triangle. So the bottom line basically is, if you have two sides, you could use Pythagoras theorem to find the length of the third side. Good. So that's basically it. Any of these two sides, if you have this side and this side, you can find the length of this side. If you have this side and this side, you can find the length of this side. And of course, if you have this side and this side, you can find the length of this side. Good. So we will get into that a little more in the next video. So we could wrap up this video now. And as always, we hope that the content is educational and informative. We try to be entertaining whenever and however we could be. But it's serious business we're about here now. Alright? So spread the word, take care of yourself, and look out for more coming your way.